Hi everyone, we're going to find the intervals of increase or decrease, find the local max and min values, find intervals of concavity and the inflection points, and use the information to sketch the graph. So the first we're going to find we're going to do the increasing and decreasing test by taking the first derivative. So the f prime of x equals, and you take the derivative and you're going to get 4x minus 4x cubed. You set that to 0, but let's go ahead and factor first. It's going to be 4x times 1 minus x squared, which equals 4x times 1 minus x times 1 plus x. So your critical values are 0, 1, and negative 1. And when you set this to 0, so we're going to let this be 0. That's what this means. Now what we're going to do is see when it is increasing and decreasing on the interval. So I'm going to do a little sign diagram here. This is your x values to give us idea when it's increasing and decreasing. And I put these in order: 0, negative 1, and 1. So I want to know what's going on with the graph. If it's increasing or decreasing when x is less than 1, when x is greater than 1, when x is in between negative 1 and 0, and when x is in between 0 and, and 1 on these intervals. So we found the intervals. Those are our intervals. And now we just plug in numbers into this. So if I plug in, say, negative 2, because negative 2 is less than negative 1. If I plug in negative 2 in this piece, I get a negative. If I plug in negative 2 in this piece, I get a positive. And negative 2 in this piece, I get a negative. Two negatives make a positive times a positive, so this is positive. That's how you do the test. That means it's positive. That's what this says. So it's increasing on this interval. All right. Now let's plug in negative 1/2. If I plug in negative 1/2, I'm going to get negative again. What color? Let's do blue. I get negative again. I'm going to get positive. Here I'm going to get a positive. So two positives is a positive times a negative. That gives me a negative. That means on this interval, it is decreasing because it says it is negative. This is what this means if it's negative. All right. Now the next one is, let's try 1/2. If I plug in 1/2, I'm going to get a positive. 1/2 here is going to give me a positive. And 1/2 here also gives me a positive. 3 positives mean it's positive. So it's increasing on the interval from 0 to 1. And then finally, the last one, let's plug in 2 for x is greater than 1. If I plug in 2, I get a positive. If I plug in a 2 here, I'm going to get a negative. And then I get my positive again. So we have an odd number of negatives. That means it's negative. So it's decreasing on that interval. And if you want, you can, let's do, if it's increasing, it's going to look like this. So it's going to look like that. Then it's decreasing from 1 to 0. We don't know the exact points. I'm just drawing the sketch. Then it's increasing from 0 to 1. And it's decreasing after that. We yet don't know how far it goes down. So basically we have 2 local maximums and 1 local minimum. Therefore, we're going to write this out on the interval from negative infinity to negative 1 and from 0 to 1. We have a local max and 2 local maxes, and they occur at let's see, f of negative 1 equals 3, and f of 1 equals 3 as well. Now for the local minimum, that's at 0. That's occurring at our 0 right there. So if you plug in, that's occurring at, it's going down on our interval from negative 1 to 0. But we have a local min there. And f of 0 equals 2. So basically when we graph this and sketch a graph, that's all we're going to do. We're going to plot these points. All right. The next step is to find concavity. And I'm going to have to take the second derivative for that. Since I already have this written here, I'm going to go ahead and take that derivative so we can see it clearly. So that's going to be 4 minus 12x squared. So there we go. That's what we're going to use. F prime of x equals 4 minus 12x squared. Now let's go ahead and factor out a 4. You get 1 minus 3x squared and set this to 0. So we're going to get 1 equals 3x squared. So 1/3 equals x squared. You square root both sides. You can get plus and minus 1 over square root of 3. So we're looking at our numbers at plus or minus 1 square root of 3. Again, let's do a sign diagram and see where we're looking for concave downward and upward. So I'm going to put negative 1 divided by square root of 3 and 1 divided by square root of 3. And remember that square root of 3 is 1.73-ish. So it's like that. So it's less than 1. So that's going to help us. Now, I'm going to plug it back in to this equation. We don't need the 4 because there's no x there and it's positive. So I'm going to plug in my values there and see what happens. So if I plug in a negative 1, say, so if I plug in, say, negative 1, this is going to, into this is going to be negative. Now if I plug in 0 in between here, let's just write this. X is less than negative 1 divided by square root of 3. This is x is greater than 1 divided by square root of 3. And now we're checking x is in between negative 1 divided by square root of 3 and 1 divided by square root of 3. So I plug in 0, I get positive. If I plug in, say, 1, I'm still going to get a negative there. Both of these are the same. So basically, these are your intervals, negative infinity to negative 1 to square root of 3. That's going to be concave down. And then from negative 1 square root of 3 to 1 square root of 3, that is concave up. And from 1 square root of 3 to infinity, that's concave down. And we're looking at those. So now that we have that, all we need to do is find our inflection point. Basically, concave down means you're doing something like concave down and then concave up. Concave down, you have some point here, then it's concaving up. That's what that is like. All right. So when I plug in, since these are both squares, I can plug in just f of both of these because it's going to, when you square out the negative, it's going to be positive. And when you plug that in, you're going to get 23 divided by 9. So that's going to be in between 3 and 4. So our inflection points occur at plus or minus 1 square root of 3 and 23 divided by 9. So we have 2 inflection points, and we have 3 other points. So let's do those. It looks like I didn't put my inflection points, so let me write them down again. Okay, I have them. All right, so basically, let's plot the inflection points. 1 over square root of 3 is a little less than 1. And then it goes to 9 goes into 23, 2 and something. So I'll just put it about here. So put it about here. Remember when you're sketching a graph, when you're sketching it, you're not supposed to really have a grid. Sketching a graph just means estimating it and stuff like that. So basically, this point here was 1, 3. This was 0, 2. So these are your 2 max. This is your min. So you're coming through up here somewhere, and you're just sketching it. And this was increasing. This side was decreasing somewhere in here. All right. Now, then it's going to be decreasing from 0 to 2. But we have these 2 inflection points. So what's happening is that it's concave down, then it's concave up. You see a little upness to it. This is a little downness to it. Now it says it's concave up from, these are the inflection points are plus and minus 1 square root of 3, comma 23 divided by 9. And at these points, it's concave up between negative 1 square root of 3 and 1 square root of 3. So even though it's going back up here, it's still concave up. There's an upswing in here. Just it's concaving up. Now it's concaving down, which we already discovered. That's concaving down. So these, let's do yellow. These are concave down, and the green part is concaving up. And that's your graph. So let me do little arrows here. Those are your inflection points. And that's just a little sketch of the graph. Thank you. Have a nice day. Bye-bye.